Hi, in this lecture we'll be getting some introduction about the algebraic vectors, and I will connect to some of the data science concepts, especially the data encoding, because this is an important concept that we will need to learn. And essentially, when we'll be using data encoding, we'll be using mostly the vector representation. So there is no separate section, but we will be using the notion of vectors and the data encoding interchangeably into this presentation. So the items will overlap, but we will need to clear our concept about when we are talking about vectors and what's its relationship to some data processing through data encoding. We'll be only concentrating on one popular data encoding for categorical data, what we call one-hot encoding. So let's start. I think most of us are aware of scalars. So scalars are numbers, for example, your height or your weight, your salary expectation when you go for a job. So these are examples of some scalars. So scalars are numeric data or maybe some sensor data. So the term vector we have learned in linear algebra, and if some of you are from physics or like some other science background, then you have learned about vectors. But here kind of same, but a little bit nuances here. So when we'll be talking about vectors in data science, we will be mostly focusing on a tuple. This is an example. And you will have two parallel representation. One we call row vectors and column vector. So again, we will have some numbers, but the numbers will always follow the same format. So this is an example case 1, 3, 4. But if you can think that this is x1, then if you have x2, then you will have to have your height and weight at the same index. So that's the notion of vector. So let's move to some formal definition. So an ordered n tuple is considered as a sequence of n terms. So you will have a sequence of n values, and n should be positive. Again, I have just already covered that when you put the data in column format, then it is called column vector. And when you put the data in the form of rows, you call it as a row vector. But essentially, you can do some transformation between those definitions. If you are actually telling that this is a row vector and I do a transpose, then that turns out to be a column vector just like this. So hope we have some idea about what the vectors are and how do we represent vectors. Okay, now I will move to a different topic, what we call data encoding. So I will take a little bit step back to connect to our digital worlds. Although our data is analog, but the computerized version of data is always digital. I think most of you have already heard that computer doesn't understand anything other than 0 and 1. So what does that mean? So that means that because if you connect to our learning of language, the characters will be the first learning unit. We learn as a child, and then we try to move from character to word and then sentence, and then we improve our language learning skills. In computing, there is two characters you can think, that 0 and 1. So these are the bit we call, and then there is a notion of computer word. When you have like multiple bits, define an entity, what we call byte. So a byte is a computer word that is formed of 8 bits. But again, the whole notion is we are learned how the digital data is encoded. First, we have a digital 0-1 encoding, and then we have a definition of byte. And we can go on and on. What I want to provide as a message in this lecture is whatever data you are looking at. For example, if you are looking at textual data or image data or video data, your medical data or the communication data, whatever data we see in real world, at the end of the day, when we format and give it to a computer to really read and store, that is represented through either bit or byte. And here comes the vector, because when you represent something, you have to formulate in a way, and the encoding should always follow the same formatting. So let's move forward. Let's start with a simple task that, okay, we are going to classify between two entities, cat or dog, We have a cat type and a dog type animal. And we know, because we know what is a cat or a dog as a human being, but there is no notion of encoding for computers that actually tell this is a cat and this is a dog. It is upon you who has to define those encodings, So here comes one popular encoding that we'll be using to encode our categorical data moving forward, what we call on-hot encoding. So it's quite simple. So you have to first find that, okay, what are the different types of entities you have for your task. So here we have two entities, a cat and a dog. You will require 2 bits to represent or encode this data. So 2 bits. So let's say you use cat to define this way. The first value is 0 and the second value is 1. And you chose to define dog through this vector representation, that the first value is 1 and the second value is 0. Or you can choose the other way, But the whole idea is that you have to form some vector representation of your entities using 0 and 1. So that is the idea of one-hot encoding. One of the bits will be 1 and the rest will be 0. It will be much clearer when we see an example for more than two categories. So let's say like we have defined cat following this format and dog following this format, So how does that look like in the Cartesian coordinate definition? The definition we have made for cat and dog follows this format. So you are saying that, okay, my data has 2 axes, or maybe my vector has 2 axes. One is x and the other one is y. I put my dog at this point and my cat at this point, And as I mentioned that if you're following one-hot encoding, then the rule applies to any categorical data. So the step is you have to find that how many values your categorical variable has to encode, and then you will use 1 for one of your vector values and the rest will be 0. So here we are representing the 3 colors. So let's assume that we are going to represent these 3 colors through one-hot encoding. So this is one format you can follow. So as I was saying that you have 3 categories, so you will need 3 bits or maybe like a 3 axis of your vector. And here in this figure, we are representing the red by triggering the first bit to be 1, the green by denoting the second bit to be 1, and for blue the third. So here you have 3 options of your colors. You will require 3 bits, and for each entities we will just make 1 bit 1 and the rest will be zeros. So you can clearly see that if you follow this format, then the red definition will be something like this, and green will be like this, and blue will be like this. But these 3 are independent vectors you are defining to denote those three colors. If you see the same representation using the Cartesian coordinate system, now because you have three coordinates, and as we defined the red to be the first value to be 1, you can quickly connect that you will have three axes. On the x-axis you will have the red values 1 and the other values are 0. For green you will have the data point something like here, and the blue will be something like here, following your definition. So this is another way of looking at how the categorical data is encoded and how they do look like in the vector space. So this is about one-hot encoding. So to summarize, you will require the number of bits equal to the number of options that you have for your categorical data, and you will choose which axis you want to put one value of your categories to be 1 and the rest to be zeros, and then you will form a vector representation of each entities in your data, and that actually calls one-hot encoding. Okay, let's look at what other formats of data you might be dealing with, and we already have explained in one of our lectures about different types of real data that we will be dealing with in our everyday lives. One popular example is the image data. For those who are not familiar with image data, if you follow what we have just explained at the beginning, it means that all the data are actually formed with 0 and 1s. So here I have three different versions of image data, and if you follow, you will learn most of the techniques that the image representation methodologies use. So first one, what we call binary image, because you see only zeros and ones, and it's a 2D format of vector, what we call matrix. So it's a binary matrix. So this is another version of image we are looking at, but you'll have varying intensities. For the binary case, we will have only zeros and ones, but here you will have a range of values, not 0 and 1. So this is what we call a grayscale image, and you can see that in the earlier image we were seeing that the matrix values are 0 and 1s, and here the values are starting from 0 to all the way to 56, that what we usually use. So it's a range of values. So again, these are actually numerical data, and again the numerical data will be transformed to 0 and 1. What about color images now? The color world is actually presented through three colors: red, green and blue. And if you pay attention, then you can quickly connect that in the color image you will have three matrices compared to grayscale image. So one matrix will represent the red part, one matrix will represent the green part, and the other one will represent the blue part. But at the end of the day, these are all digitized data. Here again, we are saying that the color image is actually a matrix, but the matrix is now three-dimensional matrix. Again, when we'll be dealing with real data, then the things will be much more clearer. But what I'm saying that whatever data we see, the computer sees in a digitized form that must follow certain encoding. We can go on and on. For example, the text data, or maybe like the video data, at the end of the day, all you have to follow certain encoding to make computer understand. And that's one of the encoding that we have learned is the one-hot encoding. Okay, that's all about this part. Thank you.